do one more Lewis structure of a polyatomic ion, and then we'll move on to VSEPR, which talks about how to figure out the shape of a molecule. So that's the VSEPR. That's what we'll get into later. But right now, let's do the Lewis structure for the polyatomic ion nitrite. Okay, so same rules as before. Nitrogen has 5 valence electrons. Oxygen has 6 valence electrons times 2. That's 12. 5 plus 12, 17. All right. Don't forget, we need to add this one in. If it was a sulfate, it would be a -2. We add 2 electrons in. If it was a phosphate, -3, you add 3 electrons in. If it was an ammonium +1, you subtract an electron. Okay, so we're adding one more. That's 18. Okay. Who's going to be the central atom? Nitrogen needs more electrons than oxygen, so we're going to put a nitrogen in the middle. And we're going to put the oxygens around it. 2 of them. Why 2? I mean, I could do it down, up. It doesn't really matter. Just put them on either side of the nitrogen because there are 2 nitrogens. Okay, we drew lines between the central atom and the peripheral atom. How many electrons did we just use up? 2, 4. We just used up 4 electrons. So we subtract 4. 18 minus 4 is 14. All right, let's distribute those 14 electrons around the periphery first. Anything left over goes onto the central atom. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Where do 13, 14 go? On the central atom. Okay, now let's take a look. Oxygen's got 8, oxygen's got 8. Can you notice that nitrogen only has 6? You can't leave it like that. The only way to remedy that is to take 1 pair from either one of the peripheral atoms. Again, we have that resonance thing going on. So let's say I take this pair over here. You got to get rid of it from here, bring it down, and now I've created an extra bond. So now I've got 2, 4, 6, 8. Nitrogen's got 8, oxygen's got 8. This oxygen's got 8. It's a perfect Lewis structure. Square brackets, put the charge out there. Perfect Lewis structure of a polyatomic ion. Okay, so I think we're all set with Lewis structures. We're ready to move on to VSEPR. VSEPR is an acronym for valence shell electron pair repulsion. And basically this theory states that the electron areas around a central atom repel each other. They don't want to be near each other. And when they repel each other, they force the molecule to take on a specific shape. So it's because these electron dense areas around the central atom repel each other that a molecule takes on its specific 3D shape. Okay, when I use the term electron dense areas, I'm just talking about the electron pairs that are around the central atom. So if you've got a single bond, that's considered one area. If you've got a double bond, that's also considered one area. If you've got a triple bond, that's also considered one area. And if you've got a lone pair, that's also considered one area. Okay, so these 4 scenarios, each one of them is considered an area. So if, for example, you had this molecule, for example, something like this, the formaldehyde that we did before. Do you remember that we did this one before? Or if you had, for example, this molecule, we did this one before, phosphorus trifluoride, we did this one before. We look at the central atom and only the central atom. You don't care about the peripheral atoms. You just look at the central atom. Okay? Just the central atom. And you see what is around the central atom. You have a single bond, a double bond. So this is considered one area, one area, one area. So this formaldehyde molecule is 3 electron dense areas. Okay, What about this molecule over here? It's got single bond, single bond, single bond, and lone pair. So this is one area, 2, 3, 4. So this would be considered 4 areas. Notice you are not paying attention to any of the peripheral atoms or any of the lone pairs around the peripheral atoms. You're just focusing on the central atom. Okay? So with that said, we are ready to start talking shapes. Now there are 2 things we're going to do. We're going to determine the electron arrangement, and we're going to talk about the molecular shape. Those are the 2 main things. Okay? The electron arrangement is strictly determined by how many areas are around the central atom. If there are 2 areas, so let's focus on the electron arrangement first. Electron arrangement. If there are 2 areas, it's called linear. If there are 3 areas, it's called trigonal planar. If there are 4 areas, it's called tetrahedral. Okay, so how the electrons are arranged around the central atom gives you these 3 scenarios. And how many, not how, how many you've got. So I have some balloons for you guys. Let's pretend that this is the central atom and pretend that each balloon is 1 area. So this could be a triple bond and a single bond, or a double bond and a double bond. So you have 2 areas. Notice how the balloons will form. They'll form this line. They're never going to be like this. They're never going to be squished this way. They will always have this linear electron arrangement because, according to VSEPR, they want to stay as far away from each other as possible. Okay, that repulsion causes this linear electron arrangement. So anytime you have 2 electron dense areas, you're going to have a linear electron arrangement. Okay, now what if you have 3 electron dense areas? Let's add in an extra balloon here. Okay, see what happens? Sort of looks like a triangle, all in one plane. So that's why they call 3 areas trigonal planar. Okay, 3 areas, trigonal planar electron arrangement. Well, what if you have 4 areas? Now there are 5 areas and 6 areas, but we don't do that in this class. This class we're just focusing on 2, 3, and 4. Okay, so if there are 4 areas, this electron arrangement is called tetrahedral. Tetrahedral. You can't have anything else. It's got to be tetrahedral. So when you do a Lewis structure and you notice that it's got 2 electron dense areas, so for example, let's say you do a Lewis structure for a molecule of carbon dioxide, and it's this. Notice it's got 2 electron dense areas. Here's 1 area and 1 area. So that means it's got a linear electron arrangement. Let's say you do the Lewis structure of formaldehyde, just like we did earlier today in the other video, sorry. How many areas do you have? 1, 2, 3, trigonal planar electron arrangement. Let's say you do the carbon tetrachloride that we did earlier, or in the other video rather. It was a carbon with 4 chlorines around it. Hopefully you guys are watching these videos in order, and hopefully you're watching all of them. Okay, notice this is 4 areas. 1, 2, 3, 4. It's got a tetrahedral electron arrangement. So if you're asked, how are the electrons arranged in this molecule? You, number 1, have to do a Lewis structure. Number 2, look at the central atom and count what's around the central atom. A single bond is an area, a double bond is an area, a triple bond is an area, a lone pair is an area. So if I had this one over here, PCl3, How many areas do I have here? Again, just the central atom. So this is 1, 2, 3, 4. Okay? So that's what you do with electron arrangements. Think balloons and think this is how the electrons are arranged around the central atom. Now, how does that affect molecular shape? That will be the next video. We're going to now tie in electron arrangement with the actual molecular geometry or molecular shape in the next video. Okay?